are online now. Yes, about the homework also I'll be discussing the homework. Okay. I have deliberately not given you the answer key for this particular assignment yet, because I wanted you people to try out the questions before you can all verify the answers and all that. I will discuss some of the questions. In some of the questions, I'll be giving you the full solution. In some, only the hint, and I will send you the answer key also. Okay. But let's first start with a quick recap of the things we learned in vectors last time, and then discuss about what we are going to learn further this time. So, recap of last lecture I talked about. So we saw the definition of vectors, what they were. So we saw that they are quantities which have magnitude and direction. Then we also discussed about the representation and notation of vectors. So notation and representation of vectors. So as a quick reminder to you about the notation and representation. About the notation, a vector is represented or notated by a symbol like this. So any alphabetical symbol with the arrow on top is read as a vector quantity. Okay. Whereas if I put that between a modulus sign, it means I'm talking about the magnitude of that vector. Okay. And sometimes in short form, we also write the magnitude as just the scalar quantity A. But in this notation, it should be understood that what I mean by the by capital A then without the vector arrow is the magnitude of it. Okay. That's about notation. Then we also saw a couple of things like unit vectors and null vector, etc. And about representation, what we saw is that a vector is represented by an arrow. So this was what we call the geometrical representation of the vector. So we talk about the geometrical representation. What we saw is any vector, let's say B or E or whatever, can be represented by an arrow such that the two properties of the vector, the two important properties of the vector are magnitude and direction. So the magnitude of the vector is directly proportional to the length of the arrow. So this quantity is directly proportional to length of the arrow. Whereas what we call the line of action of the vector or the direction. So line of action of the vector is the direction in which the vector head points or in which the arrow points. So this is what we learned about the geometrical representation. And then we had just about started that using the geometrical representation, what are the various vector operations we can do. So we had seen a couple of vector operations. So for example, we had seen in vector operations, the first thing we had seen was multiplication of a vector by a scalar. So here n is a scalar quantity. So what we saw is that n could be a number or it could be a scalar physical quantity. Okay, but importantly, it's a scalar. It does not have direction. Okay, so in that we saw a couple of important things, that if n is positive, that means the vector A is parallel to vector B. Okay, so then vector A and B are pointing in the same direction. It is just that magnitudes are in that direction. So the magnitude of vector A becomes n times the magnitude of vector B, and directionally they are parallel. Whereas we also saw that if n is negative, for example, if I said that A is equal to minus of 0.5 times B, and suppose B is a vector like this which I have drawn, then the negative sign here which we are multiplying would mean that the vector A, I'm still admitting people, but those who have just joined in, you missed about 5 minutes, but you can just have it in the, go through the video lecture later. So the negative sign here will mean that the vector A is opposite to vector B, because there's a negative sign involved over here. Okay, so it is opposite, or we can also call it anti-parallel. Whereas the magnitude of vector B will become, sorry, vector E in this case will become half of that of vector B. So if this is the direction of B, then the direction of A should be exactly opposite to this. It should be pointing opposite. Okay. And if this was the magnitude of B, whatever the length of this arrow was, that was the magnitude of B. So the length of this arrow A should actually become V by 2, because this factor is half. So this now means this, along with the fact that magnitude of the vector A is equal to 0.5 times magnitude of the vector. Notice that when I'm talking about magnitude of the vector A, I will not take the minus sign, because magnitude is a quantity which only has magnitude. It does not have algebraic sign plus or minus. It's a mod quantity, mod of A. You won't say plus or minus. You just say the quantity 0.5 or mod of minus 0.5 into mod of B. So it will become 0.5, or in this case half. So this is about the relationship between E and B. So the moment we are multiplying with the negative quantity, the direction becomes opposite. So the negative quantity over here is negative. So that means that the direction becomes opposite. And the magnitude of the quantity we are multiplying is 0.5. So that means so the length of this arrow of E should be exactly half of the length of the arrow of B, but its direction should be opposite. So this was about. And of course, we also discussed about the special case of null vector, where if you multiply a vector like B with 0, then the resultant vector A that you're getting by multiplication, that is becoming nothing but a null vector. That is a vector having 0 magnitude. Okay, so hope that aspect was clear to all of you. Now, before I come to the homework problems, I just want to quickly review a few more things that we discussed. So next thing we had seen was vector addition. Okay, and this is the part I'm going to revise in a lot of detail today before I come to the homework questions. So we had seen that we can do addition of two vectors, okay, assuming that they are given in the geometrical form. So if my two vectors are given to me in the geometrical form, that means I have the arrows which represent the two vectors. Then what kind of operation I can do to add them? So for example, if I have, let's say, just arbitrarily two vectors are given to me. So I have this arrow given as the vector E, and I have this arrow, let's say, given as the vector B. And obviously A and B have to represent the same physical quantity. Otherwise it makes no sense, we cannot add them. Remember, we cannot add a displacement vector with a force vector, or we cannot add a force vector with a momentum vector. We can only add force with force, we can only add displacement with displacement. So it's understood here that if we are trying to do an operation which involves addition, it means that the vectors we are talking about must be of same dimension, or they must be representing the same physical quantity. So that is like an understood thing over here. We're not really stating that separately, because it's just understood. Okay. So what kind of operation we will now do to add the two vectors? That is the thing. So we visualize these two vectors as two displacements, for example. So I want to now find the resultant of A plus B, which we often denote with the symbol R. And this equation that I'm writing on the right hand side, we had understood A plus B, but they are vector quantities. So this operation is called the vector addition. And vector addition, as we had learned last time, has very different rules compared to scalar addition. It's a very different thing to add two numbers like 2 and 3. That's obviously equal to 5, compared to add two displacements of 2 kilometers and 5 kilometers if they are having different directions. Okay? So literally how we do the addition here is like this, that we want to find out this quantity R. So first thing that we do over here is we pick up this vector and we pick it up and place it somewhere. So remember that if I pick up a vector without changing its direction, like I picked up that arrow without lengthening it or shortening it, or without changing its direction, then the vector remains very much the same. So I've got the same vector A, which I picked up and just placed over here. Then next what I do is I pick up the vector B, but since I'm adding A to B, so what I do is I place B where? I place B over here. Where the head of A ends, that is where I place B. Now what is the logic of doing this operation? What I'm doing is I'm finding the resultant of A and B. So to understand the logic of why I place the two arrows head to head like this, is very easy to understand. Think of A and B like a displacement. So I'm making a displacement which is A plus B. So if I started from this point over here now, so this point is where I started, this is my origin, let's say. First I made the displacement A. So that's why I picked up that arrow which I had, which represented the displacement A, and placed it at the origin. So if I had made the displacement of only A, now this would have been my final position. But then what I'm doing, I'm adding the displacement of B from here. So that is why I took the second arrow and placed it here. That now from this point I'm going here. And after completing the second displacement B, where I have ended up at this point. So now as you can see, logically, this was my initial position. This was where I started. Okay. And thinking of A and B like displacements. And this is like my final position. This is my final position. So by definition of displacement, what is the resultant sum of these two? It is nothing but this. So I'll get into formula and all that again, but just in terms of geometry, what is the operation of adding A plus B? It is just the operation of finding this third side of the triangle. Alright people, so hope this, yes, it is a parallel shift of the vector. So what I did literally over there people was, like I'll just do this operation again. So if I had this vector A, which was like this, and I want to draw the same vector somewhere else, I want to draw it from here. So I'll just shift this vector over here. So I've done it using my software of course, but literally what you will do on pen and paper is you will draw another arrow which represents this. So this vector has not changed at all, it's still the vector A. So if I just go back to this, my vector A was there. Now I want to draw another vector from this point which represents the same one. So I have to draw another arrow which is identical to that one. As long as I do that, I still have the same vector because these two are parallel supposedly, and these two are having the same magnitude. So this vector is identical to this. Okay. So this is what we mean by shifting the vector arrow without making any difference to it. So this was my operation of doing the vector addition. Now further, we had seen that if I have the magnitude of the vector A as a known quantity, it's given to me. Okay. Similarly, the magnitude of the vector B is given to me. Okay. And theta is given to me. That is, theta is the angle between A and B. This is known to me. This is also given. Then I can find out the resultant by just using a simple formula or by just using a simple operation. So that operation I'm coming back to now. So the idea is that suppose I don't have the luxury of making this triangle with a protractor and scale and all that, and actually doing the measurement of the third side to find it out. What if I have to use some kind of arithmetic or some kind of algebra to do that? So then I come to my formula method, which is called the triangle law method, where we are going to use plane geometry, things like trigonometry, Pythagoras theorem, etc., to find out how much this side would be, given that I know these two, and given also that I know this angle. This is the angle between A and B. If I know this angle and I know the magnitude of A and B, then how I can find the third side? That was the subject of our triangle vector addition. So let's quickly review that, how we did that. So how we did that was very simple. We draw the vector A. So let's say A is in any arbitrary direction like this now. And just to keep the direction of A running, so this is the direction of A. So this second line that I've drawn, the black one, is just a guideline. It's not really any vector. Now next I come back to drawing the vector B, which was here, let's say. And coming back here, this angle in between them, this was theta. So theta over here is the angle between A and B. So it's the angle between the vector A and. Now, of course, last time also we were discussing about what happens if theta becomes obtuse. No, because so far all the diagrams I made, theta is an acute angle. So I'll come to what happens when theta is obtuse also, don't worry. But at the moment, let's stick with this. And first, let's revisit this diagram or this theorem. So this was the vector A, and this here was the vector B. And now what we want to do is we want to find the resultant vector C or the resultant vector R, which is this one. So the idea is now this has become a problem of triangles for me. It's become a trigonometry problem. Trigonometry literally means the study of triangles. It has become a problem of geometry that I know this side is E. I know this side is B, and I know this angle is theta. So how much is this side going to be? So for that we use the trick that we drop a perpendicular here first. So first step in this was that we drop a perpendicular from here onto this, and then second step was we just use what we know all these years about right angle triangles, because the moment we drop the perpendicular, we have got two useful right angle triangles. The first is this smaller one. So for the smaller one here, you can see this side is X and this side is Y. Then in this triangle, the angle is theta, the hypotenuse is B, and X and Y represent the base and the perpendicular. So we have the formula that base upon hypotenuse is cos theta by definition, and perpendicular upon hypotenuse is sin theta. So still some people coming in, but it's okay. All right. So I use that, okay, and I come to the relation that okay, X is equal to B cos theta and Y is equal to B sin theta. So this was what I did. Now I concentrate on the larger triangle. So in the larger triangle, what happens? This base, this whole thing, this becomes how much? This becomes A plus X. So you can see that this base, this whole thing is now becoming A plus X. So once I can see that, I can now make use of the larger triangles trigonometry. The larger triangles trigonometry mein kya ho raha hai? I don't know this angle, of course. Okay, so this angle is an unknown quantity. So this is alpha. If this is unknown, R is unknown, but all these things are known. Capital A, capital B, and theta. These are known. So once I know capital A and capital B and theta, from that I found out X and Y. Now next thing I want to do is find the magnitude of the resultant. So since I don't know alpha, I can't use trigonometry, but I do know it's a right angle triangle. So I make use of Pythagoras theorem. So this becomes the square root of the sum of the squares of the base plus the perpendicular. So as you can see, for the larger triangle, the base is A plus X, right? And the perpendicular is Y. So obviously the hypotenuse R is becoming X, okay? And then just substituting these things over here, and I won't repeat those steps over here because they're clearly there in the last lecture, you can go through them, but we came to the important formula that R is root of A square plus B square plus 2AB cos theta. So this was my, what we call the triangle law theorem. R is nothing but the magnitude of A plus B. So we can say it like that also. So R, which is the magnitude of A plus B, is given by this formula, root of A square plus B square plus 2AB cos theta. And this is the statement of the triangle law of addition, of vector addition. And the second thing is also, of course, we wanted to find out that angle also. So coming back to the diagram here, you can see I wanted to find out this angle alpha. So to find out this angle alpha, I will make use of trigonometry again. That tan alpha is perpendicular upon base. So the perpendicular was Y and the base was that. So using that, so along with this, we also had tan alpha is equal to Y upon A plus X. Or more explicitly, tan alpha is equal to B sin theta upon A plus B cos theta, right? So these two formulae together give me both the things that I'm looking for. They give me the direction in which the resultant is and the magnitude of the resultant. Both the things which I had set out to find out, they are given by these two formulae. Right? So this is the statement of the triangle of vector addition, and we will be using this in a number of places in physics, but also in a number of places today to understand the application in more detail. Okay. So I'll just once once leave you with the general working of this so that you can internalize this, though you've done this last time, and we'll start looking at more and more applications of this now, including some of the questions that I've given in the homework problems today. So that's about what we have learned so far. Right. So just take a minute here to internalize this. Yes, Ashwini, right? Sorry, Ashani. Yeah. Yes, I will. I'll explain how to use tan inverse using a calculator also. Okay. And to answer your question, Vivek, the vector A need not lie on the x-axis. The vector A could be anywhere. Similarly, the vector B need not be on the y-axis. A could be in any direction, B could be in any direction, and theta could be any angle between A and B. So in the example diagram that I have shown, A is not along the x-axis. A is just in some arbitrary direction. Similarly, B, and more importantly, theta, which I have shown you, is nothing but an acute angle over here. But later today, we will see that theta need not be an acute angle. Theta can be an obtuse angle also. And we will learn how to adapt this formula when we are using an obtuse angle also. And Varun, to answer your question, yes, parallelogram law of vector addition is, you can say it's like a further adaptation of triangle law. The parallelogram law has two triangles, two triangles overlapped in it. And I'll be explaining about parallelogram law today. In fact, you will see that the vector addition triangle and the vector subtraction triangle, the two of them are combined in one parallelogram, and through the diagram of the parallelogram, we learn both the operations, addition of two vectors as well as subtraction of two vectors. Yeah, I'm showing the tan formula. So just coming back down here to understand the tan formula, that is this one. Okay, so far this is what we learned last time, and I will continue with more points about this and more discussion about this. But before that, there are few examples from the homework problem set that I would like to discuss a few points about. So that is why I'm going to that's why I'm going to discuss those questions to a certain extent today. And later, of course, I will send you the full answer key and on that. So next thing what we're going to do here is a bit of discussion on the homework problems. Okay? I'm not going to solve each and every problem yet. Or I can just say this is the worksheet. So I'll just give you an idea of how to approach these problems, so that next when I give the answer key, you have a better chance of getting all of them yourself. Okay, so for example, the first question, I'm just going through the question in front of me here. So I think it was something about we have to find the condition on the resultant of two vectors. Yes, it said that we have two displacements which have magnitude 3 and 4, and we have to show in what condition the angle, the resultant. So it says that if, let's say, A and B are displacements of, let's say, 3 meters and 4 meters magnitude. Okay. So we want to find the condition in which the resultant, that is A plus B, that is what we mean by resultant after all, will be of magnitude. For example, one part said magnitude 5, another part said magnitude 7, or things like that. So this is a typical thing where you have to understand what is the meaning of condition in the question. Okay. The condition literally means, see, what information is given to me in the question. The information the question is giving me about magnitude. So I have the full information about magnitude. So I don't need to find any condition about magnitude. But what information is missing in the question? The information missing in the question is about direction. Okay, yeah, 1 meter is also an option. That also. Okay. Yeah, so the information missing in the question is about the direction of the two vectors. So that means I should be able to find some kind of condition on the direction when the resultant should be 5, or some kind of condition on the direction when the resultant should be 7 or 1, like this. Okay. So here, see, I can use, yes, very good. The answer is correct, 90 degrees. See, I can use common everyday logic also, or I can use formula also. From common everyday logic, you know that 3, 4, 5 is the sides of a right angle triangle. You know that. It's a Pythagorean triplet. So you know, for example, that if the vectors A and B were put like this, if they were perpendicular to each other, then the resultant would be 5. We know that because from our knowledge of trigonometry, we have this, that if this is 3 and this is 4, and this angle between them is 90 degrees, then definitely this side has to be 5. So if this is vector A, this is vector B, then definitely this would be A plus B. So what is the condition in which the third side of the triangle would be 5? The condition is 90 degrees. So we can see that if magnitude of A plus B is 5, that implies that A is perpendicular to B, or the angle between them is 90 degrees. Okay. So this is what I meant by asking the question, that I wanted you to find a condition between A and B so that the resultant is 5. This is the condition I was looking for. Okay. Similarly, the second part, I want magnitude of A plus B to be 7. So what is the condition on that? So you can see that actually A is 3 and B is 4. So what is happening here is that the resultant is actually the sum of the magnitudes. So that means, yes, that only means one thing. This is only possible that A and B are parallel vectors, or theta is equal to 0. This is what I mean by it. Because in that case, how will the vector triangle look like? It will look like this. A is a vector of 3 along this direction. B is a vector of 4 along this direction. And the resultant of them, let us say, now I'm drawing as just as a separate this thing. This is how it will. I mean, you should draw these overlapped on each other. Here I've just drawn it like this so that you are able to understand what is happening. So this is the vector E, which is of magnitude 3. This is the vector B, which is of magnitude 4. And the only condition in which A plus B will become 7 will be if they are actually parallel to each other. Okay. 7. So similarly, you'll see in the third part, it is only possible when this happens. In the third part, what I want is, I want A to be like this, let's say. So A is a vector like this of magnitude 3, but suppose B is a vector which is actually lying in the opposite direction and of magnitude 4. So B will be like this now. This is where I'll have to, because of the limitation of my software. But just imagine these two lines are actually overlapped. So my vector B will become this one, and it's of magnitude 4. So the resultant of A and B will become which vector? The vector from here to here. Because you went through a displacement of A. So from your starting point, you made a displacement like this. And then you made a displacement of 4 like this. So this final point and this starting point, what is the displacement between them? There's nothing but 1. So you can see that that's how the resultant is becoming 1. This is the resultant of A plus B. And that's why it's magnetic. Okay. So that is one way of doing this question, because what is happening in this question, the values are actually something we are very familiar with. 3, 4 का 5 के साथ क्या relationship है? Pythagorean triplet. 3, 4 का 7 से क्या relationship है? The sum of 3 and 4 is 7. And like that 1 के साथ क्या relationship है? The difference is 1. But supposing, just supposing this is not striking us, that there is some direct relationship like this, then what to do? Even then we have a solution. Okay. Then we have the formula method of solving the same problem. So in the formula method, all we have to do is we have to substitute. So the formula method is we write out the formula. So in the formula method, we write out magnitude of a plus b as root of a square plus b square plus 2ab cos theta. So in the first case, for example, what happens is root of 3 square plus 4 square plus 2 into 3 into 4 into cos theta. This whole quantity should be equal to how much? Should be equal to 5. Now we have to solve this for theta. That's all. So the problem, as you can see, it reduces to an algebraic problem now because I'm using the vector algebra formula. Instead of drawing a geometrical shape and all that, I'm just using the formula of this thing. Okay. Yeah, Samarth, I'll explain the 1 meter displacement again. Okay. But here, what is happening is that I'm just using the formula that magnitude of a plus b is root of a square plus b square plus 2ab cos theta. So a and b individually have magnitude 3 and 4. Theta is unknown, but the resultant is supposed to be 5. So from that, I can find out how much theta is. So next step is you just square and add both the sides. So 3 square plus 4 square plus this becomes how much? 24 cos theta on the other side is 5 square. So you have 25 plus 24 cos theta is equal to 25. So this is telling you that cos theta is equal to 0. That's the only possibility. Because 25 is equal to 25 here. That means this term must be 0. So if this term is 0, obviously 24 is a non-zero quantity. So cos theta must be 0. So that is telling you from your experience in trigonometry that theta must be 90 degrees. The same thing that you have visually understood from the example of the right angle triangle also. Okay. Now similarly, if you use for the second part, yeah, exactly the point, Palak, I'm coming to. Okay, it will not give you for that. So for the second part, root of 3 square plus 4 square plus 24 cos theta, this will come out to be 7. So when you do this full calculation in this, what will come out is that cos theta is equal to 1. When you calculate this, you will see you get that, which will tell you that theta is equal to 0. Okay. Now the problem is the third part. In the third part, when you substitute mod of a plus b as 1 in the above formula, see what you get. It's very interesting. You get cos theta as a negative quantity. This is coming out to be 1. So further, 9 plus 16 plus 24 cos theta should be equal to 1 square, which by the way is 1 only. So we are getting something very interesting. We are getting 25 plus 24 cos theta is actually equal to 1. Which is giving us the further interesting result that cos theta is equal to 1 minus 25 divided by 24, which is minus 24 by 24, which is minus 1. Now this is where our difficulty starts, okay? Because till now, yes, we have not come across any situation where cos theta is minus 1. Now, I don't know if your trigonometry has reached that point yet. It might have reached that point, but in general, in 9th, 10th level, we haven't learned anything where cos theta is equal to minus 1. So we are perplexed. Then what's happening if cos theta is equal to minus 1? So later today, I will explain to you why this happens. This implies that theta is actually 180 degrees. This implies that they are anti-parallel vectors. And in about an hour more, you will understand why this happens. Very easy. You will understand logically the reason why this happens. That if cos theta is equal to minus 1, why theta should be equal to 180 degrees. So anyhow, this is the simple way of solving this question algebraically. So I'll just leave you to this first part, then I'll come to the second part. Just take a minute or so here to go through this. Okay, people, so I'm hoping so far everyone's with me. Yeah, so in this third part where it should be 1, the resultant should be 1, you can see what's happening. Think of A and B like displacements. So if you're making a displacement of 3 followed by your displacement of 4, but the resultant displacement is only 1, that means you must have taken a U-turn. Now, that is the meaning of 180 degrees. If a displacement of 3 followed by a displacement of 4 is giving you a net displacement of only 1, that can mean only one and one thing, that you took a U-turn. That's why you actually came back and then went one further back. So your net displacement is of 1. Yes, so I hear a lot of people raising the issues about how cos theta is becoming -1, and don't worry, it's a very natural doubt. The first time I heard about that also, cos theta becoming -1, it was not clear to me. But I'll explain in a little bit of time how cosine of an angle can get a negative value. Okay, but let's come back to the trigonometric approach again. Yeah, so Tarisha and Samat, what I was referring to just now was this third diagram over here. Now just see on your screens this diagram. I was saying that how can the resultant of 3 and 4 become 1? It can only become 1 in one case, that starting from here, you went 3 like this, then you came back 4 like this. So then what is your net displacement? Your net displacement is this one, and it will be 1. So that's the only possibility where the sum of 3 and 4 as vectors can give you 1. That possibility is only there when you made a 180-degree turn. That means the angle between the vectors A and B is 180 degrees. That means if this was the vector A of magnitude 3, then this should be the vector B of magnitude 4. They should be anti-parallel to each other. So that's why the result of that part was like that. Okay. So I'm just going to turn off this part and now come to the algebraic solution part. Okay. So the way actually I wanted you to solve this problem this time for this worksheet was this method, the method I've shown above, the geometrical method. That how can I arrange the two vectors A and B in a triangle so that 3 and 4 give a third side of 5, or 3 and 4 give a third side of 7. Now in this case of 7, the triangle actually collapses. It should become a straight line. Similarly, 3 and 4 is giving 1. The triangle again collapses, but such that these two are opposite to each other. Whereas in the first case they were, in the second case they were parallel to each other. So this is how I wanted you to approach the problem for this worksheet. Okay. However, for further questions, we will do it from today onwards. Another approach of doing this is the formula-based method. That in case I don't want to draw the geometrical diagram, I don't want to worry about what kind of triangle it is and what triangle formula I can apply on that. So what it becomes, it just becomes a formula-based problem. कि मेरे पास ये formula है that magnitude of a plus b is given by root of a square plus b square plus 2ab cos theta. Now in the problem, see what was mod of a plus b is given as either 5 or 7 or 1. So left hand side is given, and in the right hand side, capital A and capital B are given to me. That is, the magnitudes of the vectors A and B are given as 3 and 4. And what is the unknown quantity? It is theta. So ultimately, you see, you get an algebraic equation where only one variable is unknown, cos theta. The rest of the things are known. So it's just a matter of substituting the values, solving the equation, and coming up to this step. This step where you're getting the value of cos theta. Now for you'll see for the different cases, you'll get different cos thetas. For the case where the resultant is 5, cos theta came out to be 0. For the case where the resultant is 7, when you solve, cos theta becomes 1. And for the case where it is 1, cos theta becomes -1. Yes, ASTC is one of the principles, just to answer your question. Okay. So that is what we can use. Okay. Yeah, just a second. I'm just going through the messages. Yeah. Okay. So in the formula-based method, we substitute everything and we get different values of cos theta. Now, so far I'm saying, don't worry about ASTC and all that just now. So far, I know that when cos theta is 1, theta is 0. I have no doubt about this. So this problem is solved. I know that when cos theta is 1, okay, theta is what? Sorry, when cos theta is 0, theta is equal to 90 degrees. So this is also known. But when cos theta is -1, I'm stuck. I don't know what to do. So for that, we will learn further today. Okay, so that's why I'm saying don't worry about this just now. So that was about the first question. Now, another question I want to discuss with you. Question 2, most of you will be able to do. So don't worry. Okay, I will send you a solution and a hint to it. Okay. Now let us look at question 3. Okay. So question 3 I am going to do by a similar method. So I will now see question 3. So in the third question, it was a somewhat similar kind of language of the question, slight difference. So let me read out the question to you guys. So the question said that magnitudes of vector ABC are 12, 5 and 13. Okay. And A plus B is equal to C. So find the angle between A and B. Okay. So it is given to us that the magnitudes of A, B and C are 12, 5 and 13. So it's given that magnitude of A is 12. Magnitude of B is 5. And magnitude of C is 13. And it is given to me A plus B is equal to the vector C. So from this, what I have to do is I have to find the angle. Yes, very good, that's correct. So I have to find the angle between A and B. So I have to find theta, the angle between A and B. Just hang on a second. So now let us convert this into a vector diagram. So it means that if this is my vector E, let's say, this is my vector B, let's say, then this should be my vector C. Because in the question it is given to me that the sum of A and B is equal to C. It's given to me that the vector C is the vector sum of A and B. Now in addition to that, what is given to me that this side is 13, this side is 5, and this side is 12. And what is asked to me is this angle, the angle between A and B. So this is the thing that is asked in the question. Okay. So I can now just use the formula that I can see that magnitude of A plus B, which is basically the magnitude of C, is equal to again that formula, root of A square plus B square plus 2AB cos theta. But I think many of you would have guessed right now in this question. This is again a Pythagorean triplet. So since 13 square is actually equal to the sum of 12 square plus 5 square, 144 plus 25 is 169. So you know that the angle theta is in fact 90 degrees. So we already know this. So just substitute this here. See, 13 is equal to square root of 12 square plus 5 square plus 2 into 12 into 5 into cos theta. So when you expand this again, you come across the same thing. Cos theta should be 0. So that again means that theta is equal to 90 degrees. So that is what this question was about. So it was, in that sense, it was quite identical to the first one. Okay. So I'll just minimize this for a moment and you guys go through this. Okay. Now the next question I will discuss after this is going to be question 4. Okay. Because question 4, now from question 4 onwards, we are going to see certain types of questions where the language of the question is going to be a little confusing. Okay. So this is a common feature about questions you are going to see from this point onwards, where you have to be very careful about interpreting the question kya keh raha hai. Once you interpret what the question is saying, the rest of the knowledge you have how to solve. The whole challenge is how to understand what exactly the question is saying, comprehension of the question basically. So, I'm coming to this question 4 now. So I'll explain what the question is saying. So the question is saying that two forces of equal magnitudes act at a point. The square of their resultant is 3 times their product. Find the angle between them. Okay. The square of the resultant is 3 times their product. Okay. So let's say I have two forces like this, which are acting at a certain point. Now both the forces have same magnitude. So let's say this is force F1, this is force F2. The angle between them is some unknown theta, but they have same magnitude. So let us say magnitude of F1 is equal to magnitude of F2 is equal to some quantity x, which I don't know. Now what the question is further saying is that the resultant of the two has a certain property. So first let's draw the resultant. So this is the resultant of the two forces, this one. So this resultant is F1 plus F2 vector sum. Now read the question again carefully. What the question is saying is that the magnitude of the resultant. Okay. So I am reading the question carefully again. Okay. The square of the resultant is 3 times their product. Okay. So the magnitude of the resultant is such that the square of the resultant, that thing, is 3 times their product. So product of the two is what? X square. So this is the information that is given. और उससे मुझे क्या करना है? थीटा निकालना है. So what I have to do? Obviously I have to use triangle law. So I will use the triangle law statement that the resultant's magnitude is equal to square root of F1 square plus F2 square plus 2F1 F2 cos of theta. Now substitute all this information. So one is on the left hand side, I am getting R as what? Square root of 3x from this statement means this. And on the right hand side, just substitute R, F1 and F2 as x each. So x square plus 2x square cos theta. So now I would like you guys, if you haven't done this question, to just take this one step further and tell me from these steps, after doing all this, what will cos theta come out? Okay. Just square both the sides and solve it for cos theta and you will get the answer very easy. Just give this a try. Yes, Tarisha, good, that's correct. So this statement here, it means that R is equal to x, and that is what we are substituting. So yes, Keshan, that's correct. Good. Very good, that's correct. Okay. So solving this, you guys, you should be getting cos theta as half. So which will show you that theta is equal to how much? 60 degrees. Correct? Okay, very good. Okay. Now moving on to the carom board problem. Yes, correct. Most of you are getting it correct. I'm not going to solve the carom board problem today, okay, because it's a very nice problem and I don't want to break the problem for most of you guys, but I'm just going to give you some hint about it. Okay, so the carom board problem is like this. Imagine you have the perfectly square carom board, okay, and you have your queen that is sitting at the center. Now from here, so queen is dead center. Okay? So from here, the question says that it's 4 feet by 4 feet and all that. The queen hit by the striker moves to the front edge and rebounds and goes to the hole behind. Okay, so the path of the queen is going to be something like this, which I'm drawing next. The path of the queen is supposedly going to be like this. It goes and hits point somewhere here. Rebounds from the front, and this is what happens. So this is the path of the plane. Now, as a hint to you, what I'm going to say is that the rebounding is going to be like a reflection. Just imagine the rebounding is like a reflection. So it follows the principle that angle of incidence. If we drop a normal here, this angle should be equal to this angle. Or you can also say that if this angle is theta, then this angle should also be theta. Okay. So the moment you take that into account and you just consider another line to help you visualize the problem over here, and that is this. From the center, you draw these 4 guidelines. Okay, so you can see that now you can see that this triangle here and this triangle here are similar triangles, and they are both right angle triangles. Okay. So you can make use of that to find out the various quantities. So make use of the fact that these two triangles. So let us say this is the center point C, this is the point P where you hit it, and this is, let's say, the corners are P, Q, or let's say R, because I already used R, Q, S, T. And let's say these are the corners. So now you can see that if this midpoint over here is the point D, triangle DCP, okay, and triangle PQS are similar, okay, right angle triangles. Okay. So make use of that to find the various things which are required. So from information of that, you can make out, for example, what is the distance CP. You will be able to make out what is the distance PS, and things like that. And you have to also find the final displacement. That's also one more part of the question. So the final displacement or the net displacement of the coin is going to be this time. So by the way, you have to find the net displacement also, but that's actually the easy part of the question. The net displacement, you can see, is just root of this square plus this square. So it is 2 feet square plus 2 feet square plus square. So it is 2 feet. So the more challenging part in the question was actually these two things, finding CP and PS. And that you can do by using these. Okay. So these are going to be there in your lecture notes, which I will send to you again. So make sure you use this as a hint to solve the problem. Okay. You will get it, don't worry. This, from this point onwards. Now, question 6 I'm going to leave out for the moment, because after we finish today's practice problems, you'll get enough experience with doing this kind of thing. Question 7 I'm going to again give you a hint next. Okay, so just take a few seconds here to go through this, then I'm coming to question 7. Okay. So let me just give you the condition of question 7. So it's all diagram based. So given to you two vectors which are of same magnitude 10, and the diagram is given. Now you have to find their vector sum, which is the vector C, and the angle it makes with the x-axis. Okay. So again, deliberately I've given you a question where if you use the formula, the triangle law formula, you would get stuck. Now, because we haven't learned as yet how to solve for cosine of obtuse angles. But if you just use the geometrical method I told you, that just visualize the two things as displacements and try to find it out from the properties of the triangle, you'll see you'll be successful. So the question was like this. You are first of all given an XY axis system. So let's say this is my XY coordinate field. Now in this, two specific vectors were given, and it was given me in the question that both the vectors have same magnitude. So one vector was this one. Let's say this is the vector E, and another vector was like this. This is the vector B, let's say. Now the information given to me that these two vectors A and B they have same magnitude. They are 10 each. And also given to me that this angle is 30 degrees and this angle here is 120 degrees. Now I'm supposed to find the vector C, which is A plus B. So instead of using triangle law, let me just use geometry. Okay. So according to my geometry in this diagram, which is the vector C, it is this one. It's from the origin of A to the head of B. This vector is in fact the vector C. This is what I'm trying to find out. So now what I'll do is I'll find this out using the triangles properties only. Why? Because it's an easy triangle to solve. Why? Because two sides are equal. So when these two sides are equal, you can see these two angles will be equal. Okay. And if these two angles are, let's say, alpha each, then their sum should be equal to what? Opposite angle, exterior opposite angle. So 2 alpha should be equal to what? Should be equal to 120 degrees. Or you can even think like this, that this angle is, let's say, beta. So you can also think like this, that 2 alpha plus beta is equal to 180 degrees. So either way you can solve this one. So, and beta you can see is 180 minus 120. So whichever way you solve, you will see that alpha comes out to be 60 degrees. So that means beta is also 60 degrees, which means it's what type of triangle? It's an isosceles triangle. So there it is. Sorry, it's not isosceles, it's what type of triangle? It's an equilateral triangle. So there it is. Once it's an equilateral triangle, you can see the problem is solved. It's an equilateral triangle. So if it's an equilateral triangle, that means this side is also 10. That means this angle is 60 degrees. So what about the angle that the resultant is making with this? It is becoming 60 plus 30. So it is becoming 90 degrees. So that becomes the meaning of this. So this is the final solution of this. Okay. It means that just because it happens to be an equilateral triangle, I don't have to use any formula and all that. I can see that the resultant of A and B, that is C, that is also becoming equal to 10. And it's making an angle of 90 degrees with respect to the x-axis. And 90 degrees with x-axis. Okay. So I'll just minimize this a little bit and just get an idea of the diagram. Okay. Now, next I'll give you a quick hint about the 8th question. The 8th question is like this, that we have the minute hand of a clock, and the minute hand of the clock is of length 10 centimeters from the axis to the tip. So we have to find what is the displacement vector of its tip for from a quarter after the hour to half past after the hour. Okay? So we are talking about the minute hand of a clock. You can see that at quarter past something, let's say quarter past 10 or quarter past 12 or whatever, it points like this. It is pointing in the direction of the 15-minute thing. Okay. And at half past an hour, it will point something like this. It will point to 30 minutes. So what is the displacement of the tip of, so that's what the question is asking for. It is asking for the displacement of the tip of the minute hand from 15 minutes past the hour to 30 minutes past the hour. So it is asking for this quantity. Okay. This is the quantity the question is asking. This is what we want to find out. This is the displacement, okay, of the tip from 15 minutes to 30 minutes. Okay. So I leave this to you. This is an easy question. You can see this angle is 90, this side is equal to this side. You can work it out from there. Okay. Now next, moving on to the one question which was a little bit tricky actually in this, okay, which was the 9th question. So ninth question, why it is tricky, I'll show you, because in the ninth question I'm combining two concepts. One which I told you about multiplication of a vector with a scalar, okay, what that means, and the other is the addition of vectors. Yes. So in the ninth question, let's see what the question itself is saying. Okay, so it says that if I have a vector P and Q, I mean if I have two vectors P and Q and their resultant is R, so R is equal to P plus Q. Okay. And on reversing Q, the resultant of minus Q with P is S. So that means S is equal to P plus of minus Q. That is the meaning of the second part of the statement. Okay. So this is where we have to be, again, this is the question where language of the question is tricky. You know, we have to make sure what we mean by that. So I'm just reading out the line and you see why I've written it there. Okay. The second line of the question says, on reversing the vector Q. Okay. The second line says, yeah, on reversing the direction of Q, the resultant of this vector in brackets minus Q with the vector P is equal to S. So that is what it means. That whatever the vector Q was, okay, so let's say this was the vector Q, suppose. Now I want to reverse this vector. So that becomes this vector. When I reverse this vector, it becomes this. It becomes anti-parallel. Same magnitude but anti-parallel. This is what I would mean by reverse of this vector. This is the vector minus of. So basically how we interpret minus Q is basically equal to minus 1 multiplied by Q. It is minus 1 times Q. Therefore, the vector minus Q has the same magnitude as the vector Q, which is Q. But direction opposite. Okay. So this is the meaning of this statement. Okay. Now let's come back to the question. It says that the addition of Q with P is this vector R, but the addition of minus Q with P is this vector S. And then we have to prove or show some relationship between R and S. Okay. So we have to show that this R square plus S square is equal to 2 times P square plus P square. Okay. So let's understand this with a simple diagram. Okay. So now coming back to my original two vectors, if this is the vector P, suppose, and this is the vector Q. So they are just some random two vectors. This is P and this is the vector Q. So in this diagram, what is the vector R? R is the vector sum of these two. So R is this vector. So this one is R. Okay. Where you can see that this angle is some theta. Okay. So we have magnitude of R is root of P square plus Q square plus 2PQ cos. Okay. Now next up, I want to implement the second thing, that is about S. So how will I add P and minus Q? So I'll draw the same vector P which I've drawn above. It's just basically picking up that vector from above and putting it over here. But second thing, instead of drawing Q, what I'll draw? I'll draw minus of Q. So if Q was pointing in this direction, where is minus Q pointing? Minus Q is pointing in the opposite direction. So when I'm adding the vector minus Q with P, what is happening? I will be getting this one. This is the vector, but I'll show it in red. This is the vector which is minus Q. And now this angle over here is theta. Now, because Q was along this direction. So minus Q is becoming in that direction. Understood? So this angle theta and this angle theta, they are the opposite angles, interior opposite whatever. So now what is the vector this thing S in this? It is the sum of P and minus Q. So just think of minus Q as a new vector. So मैंने P वाला vector draw किया, फिर उस पे क्या add किया? Minus Q वाला vector add किया. So this is the final place I came to. So the addition of P and minus Q is now this new vector S. So this is okay. Now I have to do some kind of comparison between these two diagrams to prove the given relationship between P and between R and S. So how I do that comparison is, see, ये relationship कहाँ से आया था? ये relationship trigonometry use करके आया था by dropping the perpendicular here. So similarly, I have to find S by doing the same kind of operation. So this time when I do a same kind of operation here, you'll see I'll do something very interesting. When I drop the perpendicular, so hope you guys are all following up to this point. So I have taken the vector P first of all. I've taken the vector P and then I've added the vector minus of Q. So Q was like this. Follow my cursor. Q was like this. So minus Q from this point is which one? Minus Q is this one. Okay, so that is why this angle theta is the same as that angle theta. Now what is my resultant of P plus of minus Q? It is this vector. The sum of this vector and this vector is now this vector by the same logic. So what I want to find out, I want to find out this. Given that I know the length of this one, it's P. I know the length of this one, it's Q. And I know this angle theta. So this time what I do is I drop this perpendicular. I drop a perpendicular from here. And I'm dropping the perpendicular from here. What I do is I see that this side is, let's say, X. And this side is Y. And therefore this side is how much? It is P minus X. Instead of P plus X, it is now P minus X. Because this whole thing's magnitude was P. Okay. And what about this hypotenuse side? It is Q because it's the magnitude of minus Q. So once again, using trigonometry, I have the relationship that X upon Q, that is base upon hypotenuse, is cos theta. And Y upon Q is sin theta. So this is the relationship I have. And therefore, what about the magnitude of S now? That is this side. So the magnitude of S is square root of y square, that is the perpendicular square, plus the base square, which is P minus X whole square. Okay. So I'm not going to do this full derivation of this just now because we're going to use this in just a little bit of time anyway. But I would urge you to, from this point, solve the question. So from this point onwards, what we have to do is, from here and here, you substitute the values of X and Y. Okay. And you do all the steps. And on doing all the steps, finally the conclusion you will come to is that S comes out to be square root of P square plus Q square minus 2PQ cos theta. Instead of plus 2PQ cos theta, it comes out to be minus 2PQ cos theta. So now if you compare this second equation which I got with the earlier first equation which was for R, you will see, you will get the given relationship. So this was the relation for R and now this is the relationship of S. So using these two, you will be able to prove what is required, that R square plus S square. You can just square these two and add them and you will get the answer that you're looking for. So again, I would urge you to work out this question later after the class yourself by just using what I've given as a hint. Okay? So I'm first scrolling above where I have shown how to construct the vector minus Q from the given vector Q. Okay? So minus Q is a vector opposite to Q and of same magnitude. That's the first thing you have to understand. Then next thing you have to understand the language of the question. It is saying that P plus Q is a vector R, but P sum with minus Q is the vector S. And from that, it's asking you to prove the relationship between P square and Q square, which you will be doing next. Okay. So just go through this for a moment, then the algebra part for a moment, and then we will conclude this. Okay. And finally, the 10th question is very similar to the 7th question we did earlier today. So I will leave you to work that out yourself, and I will finally post the answer key after today's lecture. So after you go through this question, we will be starting with the next part of vector algebra today, and I'll explain what that is. Okay. So just go through this once. Go through this once, and then I'll scroll down below. Don't worry. Yes, so as you can see, the magnitude of minus Q is the same as the magnitude of Q. Yes, Piyush, tell me what is your doubt? Yes, Aishani, in fact, what you said is very correct. What we have done in this question, in question number 9 just now, added p with the vector minus q instead of adding with p with the vector q. That is in fact what vector subtraction is. In fact, today we will be seeing the formula for vector subtraction from this only, and we will combine the vector addition and the vector subtraction to get what is called the parallelogram law. But before that, let me just scroll down to the second part of the solution. So now compare the two triangles. See, the vector p is the same in both of them, but in one case p पे मैं क्या ऐड कर रहा हूँ, q ऐड कर रहा हूँ, और उनका सम मुझे क्या दे रहा है, r दे रहा है. But in the second case p पे मैं क्या ऐड कर रहा हूँ, मैं minus q ऐड कर रहा हूँ. I'm not adding q, I'm adding the minus of the vector q. So the sum of p and minus q is the vector s. Yeah, Piyush, so I'm coming to your question. If we reverse the direction of the arrow, can we not say that the direction of the vector is opposite instead of writing a minus sign? Yeah, so actually they are interchangeable. जो हम words में कह रहे हैं ना that it is of opposite sign, उसको हम equation के language में कैसे लिखेंगे? It is minus of. So if I say vector b is minus of a, in words that is what I mean, that b is opposite to a in direction. Yes, sir. That is in fact the application of vector subtraction, which we'll be looking at later today. Yes, yes. We are always using trigonometry and triangle properties. Okay, in entire geometrical approach to vector algebra, you will see we are using properties of triangles, whether that is Pythagoras theorem or trigonometry. Whereas when we see the second approach to vector algebra, which is something called the component method, which we'll be discussing today, you will see we will be using coordinate geometry. Now, whatever principles you learned in coordinate geometry, you learn that. All right, people. So I think we have understood this, most of us at least. Okay, so I will leave you to this at the moment. Okay, and you can complete or you can try completing the question yourself using this, and you'll see it will be quite easy from this point onwards. Okay. And as I told you, I will post the answer key so you can verify all the questions. Still, if some doubts are remaining, you can always get back to me individually also. It is no problem. Okay. So you will get the answer. Okay. Now moving on to the next thing we'll see. So we will see next today that we are back to vector addition. Now we'll see what happens. Theta is an obtuse angle, like 120 degrees or 150 degrees or any of these, or even 180 degrees for that matter. So what happens in that case? How do we find out cos theta? So in the formula, cos theta को हम कैसे निकालते हैं और sin theta को हम कैसे निकालते हैं? So for that we will see that one is we can just use the principle from trigonometry in maths, what is called the ASTC rule. Okay. So this is just like a rule, but I'll explain the logic of the rule also. The ASTC rule is like this, that if you look at the 4 quadrants, you can write them like this, that in first quadrant all are positive. So theta is less than 90 degrees. That is the first quadrant. So in that what happens? Sin theta, cos theta and tan theta all are positive. So this A stands for all. Okay. In second quadrant, if theta is between 180 degrees and 90 degrees, so this is second quadrant. So here what happens is that sin theta is positive, but cos theta and tan theta both become negative. So first we just understand this as a general rule kind of thing. Then I'll explain how the logic comes. Okay. So that is why in this ASTC rule, S here stands for sine. Okay. Similarly, in T, T stands for tan theta, and in C, C stands for cosine theta. So first of all, let's understand why this happens. I'm saying that if the angle is in the first quadrant, then all three quantities, sine, cos, and tan are positive. Whereas I'm saying if the angle is obtuse, that is between 90 and 180, then sine theta is positive, whereas cos and tan are negative. And similarly, if I say third quadrant, that is the angle is between, so for the third quadrant, the angle is between 180 and 270. Theta is between 180 degrees and 270 degrees. Third quadrant, tan theta is positive, whereas sine theta and cos theta become negative. And like that, if theta is between 270 and finally 360 degrees, that's your fourth quadrant, your cos theta is positive, whereas sine and tan are negative. Okay. So that is the ASTC rule. That's just the rule. Okay. Now we have to still discuss about the logic of the rule. So next I'll explain why this happens. That in first quadrant, while all are positive, in second quadrant only, yeah, you can memorize this, but after I give you the logic beta, you will see you won't have to memorize. You will remember it just by understanding the concept itself. Okay. So just hang on, I'll explain the logic. Okay. So in first quadrant, all three ratios are positive. In second quadrant, it so happens only sine is positive. In third quadrant, only tan is positive. And in fourth, only cos is positive. Okay. So even before we come to the logic of this, let's try and understand what does something like sine 120 mean. Okay. If I ask you, find the sine of 120 degrees, what does that mean? Or if I ask you, find the tan of 150 degrees, what does that mean? Or if I ask you, find the cos of 225 degrees, what does that mean? Right now, it should not mean anything to you. I'll tell you why. Because right now, what do we understand as sine, cos, tan? We just understand it. Okay, I have some people who are. Yeah, sorry guys if you've been waiting for long, but yeah. So what I mean is, देखो अभी तक हमारा definition of sine, cos, tan क्या होता था? It was in context of right angle triangle. Okay, so one is that we understand trigonometry for a right angle triangle. That is the only definition of trigonometry that we know till date. So in that definition, you can see that these things don't make any sense at all. If you draw any right angle triangle, this is the definition that you see. That if this angle is theta, this is the perpendicular, this is the base, and this is the hypotenuse. We know that, okay, sine theta is perpendicular upon hypotenuse and so on. We know this, ठीक है? But अभी यहाँ पे theta equal to 120 का क्या meaning है? कोई meaning ही नहीं है. Because right angle triangle में can any one angle exceed 90 degrees? It's not possible. The sum of the other two sides has to be 90. So that means when we are talking about sine, cos, tan of obtuse angle or angle in third quadrant, we are going beyond this. We are going beyond trigonometry for right angle triangle. We are going to the more general definition of sine, cos, tan. So that is where the concept comes in, that understanding sine, cos, and tan theta, okay, in all four quadrants. So what I'm teaching you here will help you equally in maths as in physics. Okay, in all four quadrants in terms of projection. So let me explain what this term projection is. So what this means is that you just assume that angle theta is just an angle by which you have rotated a rod. Okay. So you start by drawing your coordinate axis, which has all four quadrants present. Okay. So I have got x and y axis. This is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. Now let us redefine what I mean by cos theta and sin theta. So let us say that what I have is some kind of a rod, let's say, which is rotated from the x-axis through an angle of theta. Okay, and that rod is such that this length is equal to unity. It's equal to 1 centimeter or 1 meter or whatever. Okay. Now what is happening is you can see that this rod, if you drop a perpendicular here, it projects some kind of a length here, and that length is what we are calling as x. Okay. And if you drop a perpendicular on the y-axis, it projects some kind of a length here, and that length is what we call as y. So our definition of sine and cos now changes. Since the length of this is 1, x is nothing but cos theta, and y is nothing but sine theta. Just absorb this statement for a moment. Okay. Then I'll come back to the logic of it. Why I'm saying see here that x is equal to cos theta and y is equal to sine theta. Just apply trigonometry to this triangle. So I'm saying that I have this blue colored line, which just think of it physically like a rod. अभी वो rod को क्या किया है मैंने theta से rotate कर दिया है with respect to x-axis. So the moment I've rotated by theta, it is throwing some shadow on the x-axis. So that shadow is called the projection. It is called the x projection. Similarly, it's throwing some kind of shadow on the y-axis. So that shadow is called the y projection. And in short form, we just call them x and y. Now come back to trigonometry. This is a right angle triangle. This is a right angle triangle. So you can see that cos theta is x by L. Sin theta is y by L. And L is equal to 1. So naturally, what are x and y? They are sine and cos. So by this definition, and similarly, y by x is tan theta. So these are sine, cos, and tan, which are defined in terms of projection. So these are the definition of sine theta, cos theta, and tan theta in terms of what we call projection. Projection के terms में उसका meaning क्या होता है? This is the meaning. Okay. Where x is nothing but the projection of the rod's length on the x-axis. Similarly, y is nothing but the projection on the y-axis. And in very simple everyday terms, you can just think of projection क्या होता है? उसका shadow होता है. So if that rod is lying at that particular angular position theta, it casts some kind of a shadow on the x-axis. It casts some kind of a shadow on the y-axis. So just that shadow is the x projection. Just that shadow on the y-axis is the y projection. And in short form, we just call them x and y. And because we have selected a rod of unit length, x directly becomes cos theta, y directly becomes sin theta. So for example, if theta is 45 degrees, x is about 0.7, y is about 0.7, because 1 by root 2 is about 0.7. If theta is, for example, 30 degrees, then the shadow on the x-axis will be about root 3 by 2. The shadow on the y-axis will be about 0.5, like that. Okay. Now, so hope this concept is clear. Okay, just take a minute first to understand this. Okay, definition of sine theta, cos theta, and tan theta in terms of projections. So cos theta is x, sine theta is y, and tan theta is nothing but the ratio of y by x. Now, why cos theta I have not written as x by L? Because by definition I have taken L as unit length. So what are x, y, and sine theta, cos theta, etc. becoming? They are becoming the projections of the unit length or the rod of unit lengths on the x-axis and on the y-axis respectively, like that. Okay. Now the moment you do that, you will understand how I can define sine, cos, and tan for an obtuse angle. Okay. Now let's say I take the second case where now I'm going to take theta as an obtuse angle. This time theta, let's make it an obtuse angle. Okay. So theta is greater than 90 but less than 180 degrees. Okay, yeah, I'll come to this again. How y is becoming sine theta? See, ये वाले triangle को देखो वापस. In this triangle, this side is y, same as this side, and this side is L. So by definition, what is sine theta? It is perpendicular upon hypotenuse. Now that is nothing but y by 1. So here y is becoming sine theta. Similarly, cos theta is nothing but base upon hypotenuse, and L is equal to 1. So that's how. So that's how I'm getting this statement here and this statement here. Okay, guys. Yeah. So it's no problem. And all these things, the first time we are learning them, so we'll take all the time in the world. Don't worry. Okay. So now let's take the second case where theta is an obtuse angle. So we are now in quadrant 2. So first let's visualize my diagram, how that is looking, how that rod is looking and all that. So imagine now I have the same coordinate frame and all that. Yes, greater than 90 but less than 180 means that it is in the second quadrant. You will understand just in a moment why that is. So in terms of my XY system, suppose I have rotated the rod to an angle of let's say 120 degrees or something. That means starting from the x-axis, मैंने उसको ऐसा घुमा दिया है by more than 90 but less than 180. So the rod must be lying somewhere here. So when I have rotated my particular rod of length unity by an angle which is obtuse, this is the position of the rod. This is how it is looking. Now the angle is no longer acute. The angle is obtuse. You can see the angle over here is this one. This angle is theta. For example, theta could be 120 degrees or theta could be 135 degrees, something like this. Now the moment you do this, you can see that what is happening to the projections of this rod. One of the projections is on the negative x-axis. This is a negative x. You can see this is negative. Whereas the other projection which is falling, that's on the positive side. So the y projection which I've got, that one is positive. So that is the logic why in the second quadrant, what happens? Sine is positive because remember what was y? Y was sine theta. Okay, and that is positive over here because the shadow of this rod on the y-axis is falling on which side of the origin? On the positive side of the origin. But the moment the rod is here in the second quadrant, what about the shadow on the x? It is falling on the negative side. And y by x is tan theta. So obviously y is positive and x is negative. So the ratio becomes a negative quadrant. So that is why in second quadrant, what happens is that sine theta is positive, whereas cos and tan are negative. Both are negative. Okay. So just take a moment to absorb this, guys. This is very, very important. Okay? Don't worry about the time taken for this. Because once this is clear, not only of vectors, but a lot of things in trigonometry will also be clear. When you're studying trigonometric equations and maths and all, you will never have to memorize the formula ASTC. Or you won't even have to memorize how to calculate the values of cos theta and sin theta, which I'm coming to next. Okay. How tan theta is becoming negative, Piyush, is because see, tan theta is defined as the ratio of y by x. Now the y projection is positive and the x projection is negative. So the ratio of something positive by negative by definition will become negative. It is coming as per the definition of tan theta. No, it is the ratio of y by x is coming from that definition. Okay. So just take a minute. Yeah, right. Okay. Just take a minute to go through this. I'll just be back. Alright, people. So you can hopefully see I'm back, and I hope all of you understood from this. Just so far, why sine theta becomes positive, whereas cos theta becomes negative whenever we choose some obtuse angle like this. Okay. What is the sign for? The sign is for showing which side of the axis. Now you can see that over here, this length shadow which is falling on the x-axis is falling on which side? It's falling on the negative side of the origin. So that is why the value of x should be negative. Now, what is x in terms of my definition? It's cos theta. If you go back earlier, one slide earlier here, you can see cos theta was x, sin theta was y. But now, the moment I'm placing the rod such that theta is obtuse, so instead of being here, it's on that side. So instead of this being on the positive x-axis, this now what's happening? The shadow x-axis is falling on which side of the x-axis? It's falling on the negative side of x-axis. Whereas shadow on the y-axis, that's this one, is falling on which side of it? It is falling on the positive side. Okay. So that is how this is becoming positive and this is becoming negative. Okay, guys. So hope this is clear. Okay. So I have a few messages. I'll just go through them. Yeah. Now, I'm coming to that. So you guys are very smart. Now the next question you're asking is absolutely what I'm coming to. The next logical question would be is that ठीक है, अगर मैंने देख लिया कि साइन पॉजिटिव है कॉस नेगेटिव है, अब उसका वैल्यू कैसे निकालूंगा? If I ask you what is cos 120, how do I know its value should be so much? So that is where I will again make use of trigonometry. Okay. So next thing which is very important for us now, how to calculate the actual value. Okay. So this we have just seen that. Therefore, we have seen that in quadrant 2, this is what is happening. We have this information. Now the next thing that we have to explore is now how to calculate. Just a minute, guys. My board is again lagging a little. I'll reshare it. Just hang on a second. There's some people in the waiting room. You should be getting the whiteboard now. Okay. Okay. So hopefully it won't be lagging anymore. Okay. Now the next thing we are interested in here is that we have figured out कि ठीक है algebraic sign है plus minus है. Second quadrant में sin theta का sign positive है, cos theta का sign negative हो जा रहा है. But what about the value? So next thing which we have to find now is how to actually calculate. Sin theta, cos theta, and tan theta. When theta is in the second quadrant. When theta is in the second quadrant. Okay. So for that we again actually there's nothing. We just use trigonometry. It's very simple. So what we see is that coming back to this diagram. Now let me draw this in a little more detail. Okay. So this time let me label this like this. So I have dropped a perpendicular here and I have dropped a perpendicular here. So literally now what's happening is this quantity is becoming x. This is x and this quantity is becoming y. That's why you can see your x is negative, y is positive. Whereas, as we remember, the original length of the rod was unity. So this length is 1 centimeter or unit or whatever. Okay. Now, further in this, where is my angle theta? My angle theta is this one. This angle is theta. So what I'll do next is to calculate the value of x and y, I'll just make use of this right angle triangle. Okay. So in this right angle triangle, if I label this angle as alpha, okay, now it's something I'm more used to because alpha is an acute angle. So you can see, first of all, alpha is equal to how much? It is 180 minus theta. Okay. So for example, if theta was 120 degrees, then that alpha is becoming how much? It's becoming 60 degrees. Or if theta is 135 degrees, then that angle alpha is becoming 45 degrees. Okay. So now this triangle which I've shown, this is a manageable triangle for me. Okay, what's happening for this triangle is that the hypotenuse is unity. It's L, which is unity. Okay, 1 unit. Whereas this is Y and this is X. So for that triangle, now I'm drawing it separately over here. This angle is alpha, this is Y, this is X. So just in terms of magnitudes, without sign, right? If I just talk in terms of magnitude, so magnitude of Y by L, I'm not worried about the sign right now, is how much? It is just sine alpha. Okay. And magnitude of X divided by magnitude of L is how much? It is just cos theta. So now coming back in my diagram with sign, okay, X is actually becoming how much? It is becoming minus of L. Sorry, this is not theta, this is alpha. So X's sign is what? X's sign is actually negative. So it is minus L cos alpha. So X was basically what? It was cos theta. And L was how much? It was unity. So it is becoming minus cos alpha. So this is like my first formula. That अगर मुझे थीटा का वैल्यू पता है तो 180 माइनस थीटा अल्फा का वैल्यू पता है तो cos थीटा कितना हो जाएगा? माइनस ऑफ cos अल्फा हो जाएगा. Similarly, y in the above equation was positive. So y is what? It is positive of L sin alpha. And what was y? It was nothing but sin theta. So sin theta is becoming positive of sin alpha. Okay. And tan theta I can always just write like this. Tan theta by definition is sin theta divided by cos theta, or just y by x. So yes, I'm explaining it again. So tan theta is becoming minus tan alpha. So these three formulae actually give me a way of finding out the value. Okay. So I'll take you through the steps again. So first of all, what I've done is I've rotated my rod of unit length L by some kind of an obtuse angle, like let's say 120 degrees or 135 degrees or whatever. So it's positioned like this now. Now, if I look, this angle theta is obtuse. That means this remaining angle over here, the complementary angle, is an acute angle. So I label that angle as alpha. So you can see by definition, this angle here, the one is making with the negative x-axis. That angle is how much? It is 180 minus theta, and that is an obtuse angle. For theta 120, that angle is 60. For theta equal to 135, that angle is 45. Now, why I'm doing that? Because once I label that angle, I can now concentrate on this triangle. Instead of worrying about this whole diagram with this 120, I can just concentrate on the trigonometry of this triangle, the right angle triangle type of trigonometry that you're used to tilting. So just now, for a moment, just forget about second quadrant and all that. Just imagine that you just picked up this triangle separately and you placed it here. तो ये triangle की जो side lengths है, just in terms of magnitude, वो क्या है? Mod x, mod y and mod l. Okay, so apply trigonometry there. So mod y by mod l is nothing but sin alpha. Mod x by mod l is nothing but cos alpha. So you got the value of magnitude of x and magnitude of y. Okay, now come back to my quadrant situation. So I'm in the second quadrant. So I know my x coordinate is which kind of quantity? It's a negative quantity. So from here, see, I already know the magnitude of x is L cos alpha. So with sign, it is becoming how much? It is becoming minus L cos alpha. But the magnitude of y is mod L sin alpha, and the sign of y is positive. So y further is becoming how much? It's becoming plus L sin alpha. And that's why your tan theta will become y by x. So that will become negative later. But for the moment, just concentrate on x and y. So x's magnitude is L cos alpha, but what about its sign? It's negative. Y's magnitude here is how much? It is L sin alpha, but what about its sign? It's lying on the positive side of the axis. So y is becoming plus L sin alpha. And that is why now by definition मेरा x क्या था? Cos theta था. और मेरा y क्या था? Sin theta था. So by definition cos theta is becoming how much? Minus cos alpha, because L is unity. And what is sin theta? It is nothing but plus of cos alpha. So now this gives me a formula. Because see, for example, if theta, why is the sign negative? Because see, go back to the quadrant diagram now. No, because you're now interpreting x as what? You're interpreting it with sign. No? So the quadrant is important. So when this rod is lying in the second quadrant by theta being obtuse, इसका जो projection x axis पे वो कहाँ पे गिर रहा है? That projection is not following on the positive x axis. That projection is now in fact falling on the negative x axis. No? This is the negative x axis. That is why this is negative. Whereas this is falling on the positive y axis, so this is positive. So that's why x's value will be negative times its magnitude. Its magnitude is L cos alpha, but its sign is negative. And further L is 1, so it's nothing but minus cos alpha. And by that now, what is the definition of x itself? It is cos theta. So what is cos theta becoming? It's becoming minus cos alpha. So for example, if theta is equal to 120, then alpha is equal to 60 degrees. So what is cos theta by this definition? Cos 120 should be minus of cos 60. So it should be how much? It should be minus of half. So there you are. Now we've got a way of calculating cos 120. We've got a formula of calculating cos 120. We're just applying this formula. Okay, so if I know the angle is 120, then I should calculate this thing of that angle. Just excuse me for a moment. Yeah, sorry guys. So coming back to this, now what is happening you can see is the magnitude of x and y you got from here, mod L cos theta and mod L sin alpha. But now giving the sign, we are getting these two formulae, that cos of theta is minus cos alpha, whereas sin of theta is plus sin alpha. Okay. How did x become cos theta? Because that is what the definition of x was. See, coming back to our new definition of x and y. One was trigonometry in right angle triangle. That is what we are used to till date. But today we moved on to what? We moved on to the definition of sine cos tan in terms of projection. This definition. Okay. So here what we saw, what is the definition of cos theta? It is nothing but x. And what is x? It is the projection of that rod on the x-axis. What is the definition of sine theta? It is nothing but y. It is the projection of the rod of unit length. So the fact that I've equated x with cos theta and y with sin theta, that is coming from the new interpretation ki sin theta cos theta kya hota hai. Now I'm not thinking in terms of right angle triangle anymore. I'm thinking in terms of the projection of a rod of unit length when that rod is rotated by an angle theta. So uska x axis pe shadow kitna gir raha hai, that is my cos theta. Uska y axis pe shadow kitna gir raha hai, that is my sin theta. And that is why x is cos theta and that is why y is sin theta. So now that's what I'm using over here. And that is why I have equated x with what? Cos theta, and I have equated y with what? Sin theta. And from that I am getting now this relationship. Okay. So from this relationship you can therefore also see that yeah, 122 will be a problem because see okay, I'll come back to this. Okay, I'll come back to your question later, just a moment. But for theta equal to 120, you can see how easy it is. So therefore, what this formula is now showing me, this formula is showing me that sine of 120 is how much? It is positive of sine 60. Okay, that is nothing but root 3 by 2. Yes, that is correct. Okay, so in fact, and similarly, we can see that tan of 120. Now tan के लिए see you don't need to apply any other formula. You already know sine and cos ना. तो sine मेरा कितना था? root 3 by 2. Cos मेरा कितना हो गया? minus half. So उनका ratio कितना हो जाएगा? minus 4. So tan of 120 is just coming from the ratio. Okay, so in fact now you can develop a formula like this. Okay, so we can develop the formula for second quadrant. So we can just simplify all these things that we've written. So formulae for theta being between 90 and 180 degrees. Okay. We can actually even include 180 in this. We'll see in a moment. Okay. So this is second quadrant. So what is the formula we can use? That cos theta was minus of cos alpha, or alpha actually क्या था? 180 minus theta. So cos theta is minus of cos 180 minus theta, and sin theta is positive of sin 180 minus theta, and tan theta is again minus of tan 180 minus theta. That 180 minus theta only in the previous case was the alpha which I did. So I just replaced that alpha with this. So this becomes like a set of master formulae that I can use for second quadrant. Yes, these formulae are universal actually, and why they are universal you will understand later also. They will also apply to cases where theta are going beyond this range of 90 to 180. You can apply it to theta in the third quadrant, fourth quadrant, or even something very random like theta equal to 756 degrees, which is after two rotations, because 360, 720, then 756. Okay, but for the moment, let us just say that we are sticking to the second quadrant. So whenever we have an angle which is between 90 and 180, we use these formulas. You can think of this formula. Now, as you can see, you don't need to memorize this formula, because you can always think of this formula in context of this diagram which I made. Yeah, and you will understand the logic behind this formula. So you don't need to rote memorize them. You just need to logically understand them and practice them out a little bit, of course. Okay? So which is what we are coming to. We are coming to practice in the next section. So, for example, using this formula now, I will ask you to find out. Let's do a simple problem first. So find the following. Tan 150. Okay. This is very lame because I just gave you this one. Okay, guys, yeah, just work this out quickly. Good. Aditya, Soham, Dhruv, and Sunny. Yeah, you people have got the idea of this now. Correct. Piyush. But Piyush, be careful about sign. Yes, so Arya, in that now you have to substitute now. Alpha will be 30 degrees, so substitute the value and find how much is tan alpha. Correct. So we'll just see here how we can make use of these formulas and solve this. So for example, tan 150. Now I'll use this formula that tan theta is minus of tan 180 minus theta. So making use of this, tan 150 degrees is minus of tan 30 degrees. So it's minus of 1 by, that's the first part. Sin 120 though anyway found out earlier. So this is plus half, plus root 3 by 2. Okay. Now let's come to cos 135. So cos 135 we'll write as minus of cos. So in second quadrant, cos is negative. 180 minus 130. That is minus of cos 45 degrees. That is minus 1 by So this is the simple way. Yeah, yeah, Piyush. Yes, true. That's correct. What you're saying. Okay, 5337 triangle has that relation. Yes, Piyush. Your answers are correct, as you can see. And what was the last one? Sine of 127. Okay. So this is one special triangle which you're not used to much, but you will gradually get very used to as we do more of vectors. So we wanted to find out sine of 127 degrees. So that will become sine is positive in the second quadrant. So positive of sine 180 minus 127. So that is positive of sine 53 degrees. Now 53 may not be a one which you are familiar with. So but I was telling you last time, if you remember, that there is one very common type of triangle, the 3-4-5 triangle, that you should become familiar with. So if we draw the 3-4-5 triangle such that the base is the smaller side, that is 3, and this is the larger side, then this angle is 53 degrees. Okay. Or if you just invert this triangle a little bit, you can draw it like this. Then the angle you're concerned with is the supplement of 53. So, these are two common triangles that, I mean, this is the same triangle actually, but so these are two common cases that you will get more and more familiar with. Just like you're familiar with 30, 45 and all this. So here this angle was 37. Here this angle is 50. Okay. So this is just something to get used to. Okay, so sine 53, you will see is the same as cos 37. It's the same thing as 4 by 5. And similarly, cos 53 is the same thing as sine of 37, which you see is 3 by 5. Okay. And it's very easy to remember this because they go 3-4-5 triangle. So 4 is the larger of the two perpendicular sides. So 4 के opposite जो angle होगा वो ज़्यादा होगा, वो 53 होगा, और 3 के opposite जो angle होगा वो छोटा होगा, वो 37 होगा. If you just remember that a 3-4-5 triangle has the angles 37 and 53, it's very easy to remember this logically. And tan 53 is the same thing as cot 37, which is 4 by. So these are the formulas. So now we substitute that back in that question. So substituting this over here, this becomes plus of 4 by 5. Or you can say it is plus of 0.3. So that's your sine 127 degrees. Okay guys, so that's just a special angle 53. Okay. As I was telling you, by the end of this chapter vectors you will get used to it because we use it many a time. Okay, so this is about the obtuse angles. Okay, so just before we wind up for today, we'll see how to use this in our parallelogram law of vector addition. Yes, of course, Samad, that is true. There can be many other triangles which have all sorts of random angles. Like what about sine of 36 degrees? Or what about sine of 27 degrees or like that? So for that, we have the sine cos tables. In fact, at the end of today's lectures, I will show you how to use a scientific calculator in an Android phone or even an iPhone or something and find out the sine cos tan of any given angle. Okay, so I'll come to that also. Okay. So now let us look at the application of this in vectors, in vector sum. So back to addition of vectors. Now, suppose I incorporate this information here. Let's see how we make use of this. So let's just directly come to a numerical example. So in my next example, I have magnitude of vector E is, let us say, 20. Okay. Magnitude of vector B is 10 root 2, or approximately 14.14. And theta is equal to 135 degrees. That is the angle between E and B. Okay. Now here's what I want you people to do very carefully. So the steps that I want you to work out in the question is, first of all, given that C is equal to A plus B, draw a vector triangle to represent A, B, and C. And secondly, find the magnitude of the vector C. And third, find the angle of vector C with respect to vector E. Okay. So as you can see, it is just an application of vector addition by triangle law that we discussed today. But the only thing is, this is becoming one of the first examples we're doing where we are making use of an obtuse angle. So we are making use of all the things that we just learned. That is the trigonometry of angles in second quadrant. So hopefully you've scribbled down some of those formulae, so you'll be able to refer to them as you're solving this. Aditya, check your answer once more. That's in fact not correct. Yes, people. So I'm just checking the answers. Yes. Okay, so yes, some of you have got it correct. That's a good sign. Okay, so let me just, because a lot of people are answering, so let me just first draw the vector diagram. So I have my vector E, which was of magnitude how much? Magnitude 20. And B, which was of magnitude 10 root 2, but at an angle of this thing. 135. So if I represent vector E with this one, suppose, and it's of magnitude 20. And now let's say I represent vector B. Now the important thing, the direction. Okay, so this is where things become very tricky. Okay, this is where you have to be very careful and clear about how you understand things. So this is the direction of E. अभी यहाँ से मुझे कितना एंगल बनाना है, यहाँ से मुझे एंगल बनाना है 135. So that is why my vector v will actually have to lie along some direction like this. This is what I mean by v making an obtuse angle. So v will be like this. Alright now. Now b won't be quite as long as a, because remember b's magnitude was 10 root 2. It's only about 14 point something. So just estimated it will look something like this, 10 root 2 or approximately 14.14. But more importantly, this angle is now how much? It is 135 degrees. Okay. And in the scheme of these things, now c is equal to a plus b. So how is the vector c looking in this? The vector c must be looking like this one. This is what my vector c is. Okay. So this was the first part, just the figure. Okay. Now the next thing is, I don't expect you to solve this by using any geometry and all that, because I have a formula. So why do we use geometry now? Okay. This was just because the question asked. Because I wouldn't have done that. I would have just directly used the formula. Okay. So let us see the application. Okay. So I want to find out. So this is, so mod A is 20, mod B is 10 root 2, and theta is 135 degrees. So I want to find the magnitude of C, which is basically the magnitude of the resultant of A and B. So that is going to be root of A square plus B square plus 2AB cos theta. So that is A square is 20 square, B square is 10 root 2 the whole square, and this will become 2 into 20 into 10 root 2 into cos 135 degrees. So this is our calculation. Now next thing in this, before we proceed, what is cos 135? It is cos of 180 degrees minus 45. Correct. And second quadrant cos, as we just discussed, is negative. So it's minus cos 45. So it is minus 1 by root. Now let's see what we get when we substitute in the above formula. So magnitude of C is becoming 400 plus 200, right? Because 10 square is 100 and root 2 square is 2. So 200 plus ये कितना हो जाएगा C? 400. Okay, root 2, that's this part. 2 into 20 into 10 root 2 multiplied by cos 135. So cos 135 we are just seeing is this. It is minus 1 by root 2. Okay. This is cos. So we are substituting this over here. So on substituting this here, we get this. Correct. So that's how, next interestingly you can see, you get C as square root of 200. Now, because this term and this term cancels out. 400 plus 200 minus 400. Right? So as you can see, this becomes this way. So it becomes 10 root 2. Okay, that's the first thing. So that's approximately 14.14. Alright guys, so that was about the calculation of this. Okay. Now just minimizing this to show you the calculations. Now we have to come to the third part where we are finding the angle also. So in this figure now, the only thing remaining for us to do is we have to also find this angle. This angle. We found out the magnitude of C. We found out. Okay. Now for the angle, remember what was the formula? Tan alpha is B sine theta upon A plus B cos theta. So we are just going to make use of that formula. Okay. So we will make use of this formula. So tan alpha is B sine theta upon A plus B cos theta. Now I'm just going to write again over here. A was 20, B was 10 root 2. But more importantly, cos theta was minus 1 by root 2. Okay. This already I know from before, so I'm using that. What about sine theta? So let's look at that once more. So that is sine of 135 degrees. That second quadrant sine is what? It's positive. So it's positive of sine 180 minus 135. Okay. So again that formula. Okay. And that formula is coming from where? It's coming from the projection method or the ASTC rule. So this is positive of sine 45. So it is 1 by root 2. Okay. So because sine is positive in the second quadrant, whereas cos is negative, you see we are going to substitute a positive value of sine theta, but a negative value of cos theta in this formula. So this becomes equally important. So now substituting 10 root 2 into positive of 1 by root 2. That's my numerator. Upon A plus B cos theta. So that is 20 plus of 10 root 2 into minus 1 by 2. Right. So as you can see, this becomes 10 upon 20 minus 10. So very interestingly, it becomes unity. So tan alpha is unity, means that alpha is how much? Alpha is 45 degrees. Okay. Now as an exercise for you, what I would recommend also that when you are reviewing this question and its solution today, you try to get this result that we got by solving that triangle also. Now you will be able to actually get these answers by just solving that triangle also. It's a little more complicated and it's a little more lengthy, but you can actually get this value of C, which is 10 root 2, and this value of alpha, which is 45, by just doing a little bit of geometrical construction on this triangle. Now, just a bit of manipulation, like we were doing with the solution of the worksheet earlier today, and that kind of thing. Before we had the whole knowledge of how to calculate cos of obtuse angle and all that, I was using triangle geometry to solve this. So you can try that as an alternate method also, and you can get confidence in this. Okay. So this is about the complete solution of this. And with this, actually, you can see that we have completed the first sort of real vector operation in detail, which is the operation of vector addition. Yeah, I'm coming to scientific calculator. Now, as you can see in all these questions, the value given by the paper setter, or in this case by me who has put up the question, is such that they are all coming down neatly. Now, I'm getting the value of tan alpha as 1. But what if while solving this, I got the value of tan alpha as 0.8 or 0.75 or 0.32 or something? What I would do in that case? Okay. So I have two options. One is I can go to the sine cos tan tables, which is very tedious, or I can make use of a scientific calculator. So guys, I'm going to demonstrate using a scientific calculator to calculate some values. Okay, so now I'm moving away from this question and all this. So I'm moving into my Android phone, which hopefully you will be able to see on your screen when I put it up. Okay, so first of all, I'll stop this sharing here. Just hang on a second, guys. Okay. Okay, so I've stopped the screen sharing. Okay, now what I'm going to do is I'm going to first show you a screenshot of my Android Android calculator. Okay. So this is the Android calculator on my phone, guys. Okay. So this is a calculator which is downloadable. Any real calculator, this calculator, that calculator. You can just go to Google Play Store, or on iOS you can go to Apple Store, and you can just search for scientific calculator and download the app, and you will come across something like this. Okay. Now in this, you can see, there is the shift button. You see the yellow colored button on top. On the top row, you see the shift button. So that shift means that it gives you inverse function. Okay, so I'll just explain to it in a minute. Let me see if I can do this better. Yeah, this is easier for me. Yeah, so you see this shift button over here, which I'm going to press just now. Okay, this button is called shift. Okay, so what it does is it applies the inverse function. So next you see there is sine, there is cos, there is tan. Okay, those are the regular functions. So for example, if I type 30 degrees, okay, so I have typed 30 over here, and now I want to calculate sine of 30. So next what I'll do is I'll type sine. So it gives me 0.5. That is sine of 30. Okay. Similarly, if I type, for example, 45 degrees, it will give me, and then I type, for example, cos. Now cos of 45 is 1 by root 2, which I told you, remember, today is very close to 0.7, 1 by root 2. So it's giving me that. Okay. Similarly, for example, if I type 90 degrees and then type cos, you should get 0. So see, you're getting 0. If I type 90 degrees, but I type sine, it should give you unity. Okay, let's see what 90 degrees tan gives us. It's an undefined quantity, but let's see what the calculator gives us. It gives us error, which means it's undefined. Okay, so no problem. Okay, now this is not important. What I'm showing you is the inverse of that. Okay, now suppose I have an equation which is telling me that tan theta is equal to, let's say 0.8. Okay, tan theta 0.8. Now I know that theta will be very close to 45. Because tan 45 is 1 and 0.8 is very close to 1, because tan goes all the way to infinity, remember. But I want the exact value of angle. So what I have to use is I have to use the inverse tan function. So now you see above the tan, there is this small yellow colored icon which says tan to the power minus 1. Do you see that? Above tan, there is tan to the power minus 1. Similarly, above cos, there is cos to the power minus 1. Above sine, there is sine to the power minus 1. So these are what are called the inverse functions. So these functions are used to find the inverse operation. Yes, it is what is called inverse trigonometry. So coming back to this, I have tan of some angle is 0.8. Okay, so let's say I have got the equation tan theta. If you like, you can write on your notebook. I have got tan theta is equal to 0.8. So now I want to find out theta. So tan theta is equal to 0.8 and theta is equal to question mark. So what I do is I substitute, I type in 0.8 in the calculator. Okay, and instead of finding tan, I want to find which angle ka tan is 0.8. Understand what I'm doing? I'm not trying to find out tan of 0.8. I'm trying to find out ki kaun se angle ka tan is 0.8. So what I'll do is on 0.8, what I'll operate is tan inverse. So tan inverse of 0.8 will be this. I have typed 0.8, then I type shift. So shift means I'll be using the function on top. I'll be using tan inverse and not tan. So when I type shift, I don't know whether you'll be able to see on my screen. This shift has appeared on the screen here. See, I'm going to again type it, so that shift is gone. So it's not applied anymore. When I type shift again, that shift function has appeared on my screen. So that means now I'm using the shift functions. So I'm going to use shift of tan, which is nothing but tan inverse. So what I'm going to get? 38.65 degrees. So that means 38.65 degrees ka tan kitna hai? 0.8. Similarly, if I just want to check this, I know that tan 45 is 1. So let's verify that. So I type 1. And now I want to find kaun se angle ka tan 45 hai. So I do shift tan. That is tan inverse of this. You see, I get 45. I want to find kaun se angle ka sine is 0.5 or half. So I type 0.5. And then I want to do the inverse sine function. So shift of sine. So see, I get 30 degrees. I know sine 30 is half. So sine inverse of 30 half is how much? 30 degrees. Earlier today we were talking about this thing. We were talking about 37 and 53. So we just discussed sine 37 is how much? 3 by 5. So that is 0.6. So 3 divided by 5. That's 0.6. Now I want to find kaun se angle ka sine 3 by 5 hai. So I do shift of sine and see, I get 36.8, but very close to 37 degrees. So 37 degrees is the approximate value of the angle. Similarly, 4 by 5 was 0.8. So 0.8 का sin inverse कितना होगा? It should be around 53 degrees. So let's see. Yes, we get 53.13 like that. So that is how we use a scientific calculator to find the value of angles when I know either sine, cos, or tan. So if I know tan theta is, for example, 0.2, how will I find theta? So I'll type 0.2 and then I'll type shift tan. So it will tell me that tan of 11.3 degrees is 0.2. Like that. Okay, so that is how you can use a scientific calculator. However, remember that for your JEE level questions, your questions will always be set in such a way that the values mostly come in terms of known angles. All right, guys. So this is where we conclude today's lecture, and with this, we are done with vector addition using the triangle law. So I will now be giving you some work to do from your module as well as some worksheet. In the module, I will refer to exact page number and sections of it which you have to read and all that, and then attempt certain questions. So in many ways, what we have done in today's lecture, actually half of last lecture and today's lecture, that is the first lecture of vectors. You'll remember that 1 hour was kind of an introduction to physics, and then we understood the basics of what vectors are and all that. So by the time we actually came to the subject of vectors, it was the second hour of last lecture. So this is the first lecture of this. Okay. Yeah, I will. Just a minute. I just got some message. Drop the link to the app. Yeah, I'll drop the link to a scientific calculator app also. Don't worry. But you can just search for any scientific calculator. Scientific calculator on Google Play or this thing Apple Store or whatever. If you search, you will find n number of options of that. In that, the one I use is called the real calculator. I find the interface easy. Otherwise, any calculator. Don't worry. Okay. So that's it for me today, guys. Hope you guys have enjoyed the lecture and understood. I have enjoyed bringing it to you. And God bless and stay healthy. Okay. And what else can I say? Okay, just hang in there. I know it's difficult. No football, no cricket, no hanging out. Only studies, only TV. But okay, just hang in there, guys. Okay, all the best. And I'll be meeting some of you soon in the mentoring sessions. Meanwhile, any doubts that you have otherwise, do not wait for the mentoring session. You can just directly message me for any questions and doubts. That's it for me, guys. Bye.
लेक्चर में म्यूट बटन है अनम्यूट इदा
हाँ लीव मीटिंग है, मैं जाकर के मम्मी को फोन दे रही हूँ।